Lesson 3, Deryck teaches R programming. Lesson 2, we did a simple calculation of calculating the mean standard deviation. Actually, lesson 3, this program is not any more complicated than lesson 2. I'm just giving you another example of a program. This program will have more lines, but the calculations are just as simple. Let's go through it. So today's problem, we want to calculate the monthly payments of a mortgage. So let's suppose we have a mortgage of $200,000 at a rate of 3.75 for 15 years or 180 months. Let's create a SAS program and find out what the answer is. Here's our contamination problem from last time. I'm just going to close this and create a new program. You're going to use the hashtags to label the program, and we're going to give it a title or a description. So this program calculates the monthly payment of a mortgage. And then what we're going to do next is we're going to set variables to store the different attributes of the mortgage. So first off is the principal. Let's just say it's $200,000 is the total value of the property that we have purchased. Interest rate 3.75. Then the months. So for 15 years and 12 months per year, 15 times 12 equals 180. The first thing we want to do is we want to manipulate the interest rate so it's a number that we can use. Step 1, assign to the variable step 1 a rate. We're going to take the rate and divide it by 1200. And then the reason we're going to do divide the rate by 1200, and I can add comments to each part of my program that describe it. I actually have the comments here on the side. I'm not going to type them all. I'm going to paste them in. So the purpose of this formula is two things. It converts the interest rate into a decimal by dividing it by 100, and then converts the annual interest into a monthly interest rate by dividing it by 12. The next thing I want to do is I want to calculate the compounding interest. Step 2, I'm going to call this next variable step 2. And then I am going to create this formula here. So I'm going to take the formulated monthly interest in step 1, and I'm going to find the exponent, 1 plus step 1 exponent, total number of months. And the reason I'm doing this, I'm going to calculate the compounding interest. My next variable, I'm going to call it step 3. Keep it all lowercase though. Assign. So the purpose of this next formula, I'm going to manipulate and combine the two steps, the compounding interest and the monthly decimal interest in order to create a dividing factor where I can divide the principal into its monthly payments. So step 3 is a calculation that multiplies step 1 times step 2 divided by step 2 minus 1. Just add some comments here. The last step is to calculate the monthly payment amount. So I'm going to call this variable monthly payment. Oops, assign step 3 times the principal. So I have 4 steps, 4 parts to this program, but I still haven't created a command that gives me the output. I'm going to use the cat statement instead of the print statement. And I'm going to create my labels. I'm going to align my labels with my data. So the principal, I want the program to display the principal, and then I'm going to put the variable principal. And then the rate. RATE. Is that correct? Let me just expand this, make sure. Months. And then the last part is the monthly payment. Correct. Monthly payment. One of the cool things about Notepad++ is I can double click these words and see where they repeat. They get highlighted in green. So I can look for any sort of syntax errors. So it tells me where I have matching words in order to figure out, making sure that my variables are all matching. So in any of the non-green area, I'm looking for the word principal and I don't see it, which is good. I can do that with rate. Then months. Save this to my R programming folder. I'm going to call this program mortgage.r. Close this. Open my R programming environment. Open my source code, source R code, choose mortgage. There's my results. So in order for the output to fit in one line, R is shortened the value of the principal. The 200,000 principal amount is there. It's just represented in an exponent format. The rate's there, 3.75, total number of months, and the monthly payment that's calculated is 1,454. And that's the end of today's lesson.